Good morning, dear children. Today we are going to discuss about a new physical quantity which we will often use in the motion of objects, that is acceleration. And this physical quantity is always denoted by the small letter A. So in motor vehicles, mainly this particular physical quantity is more relevant. Can you identify a similar term which we will often use in the case of motion of vehicles? Actually, it is a tool or it is a part of the vehicle. Yes, it is accelerator. Yes, accelerator of the vehicle. And do you know for what we are using this particular device in a vehicle? Yes, to speed up, isn't it? That means to increase the speed, we are using this accelerator in the motor vehicles. And similarly, there is another device, another mechanical device in the vehicles for speeding down or to lower the speed. What is that particular device called? Yes, it is brakes, isn't it? So, brakes to speed down and accelerator we are using to speed up the vehicle. That means we are increasing and decreasing the speed of a vehicle with respect to time. When we talk about vehicles, they will often changes its direction. So speed with the direction is changed with respect to time. That is, velocity is changing with respect to time. Clear? So here we are using the term accelerator. That means it is increasing the speed. Here we are using a tool called brakes to speed down. So that means what it is doing? It is reducing. So it is called decelerator. What it is called? Decelerator, or it is decelerating the motion. Decelerating means speeding down or lowering the speed. Clear? Now, let us observe the motion of a bus on a straight road. Now, the bus is moving on a straight road. Suddenly, the driver applies the brake and it is slowing down the speed and stopped. Can you observe this? That means the driver applied the brake. That means the driver wants to slow down the vehicle and slowly it came to a stop. Again, the driver starts from the rest position and gradually he is increasing the speed, and here you can see the speedometer reading. And you can see that the needle of the speedometer is changing. That means it is showing the speed at that particular instant. It is increasing the speed. Can you observe that readings on the speedometer? Yes. Till now the bus was traveling through a straight road. That means it is changing, or it was changing only its speed, not direction. That means velocity was not changing. What was changing? Only speed was changing because it was moving on a straight road. Now you can observe here that it came to a turn. That means the bus has to change its direction also. So speed along with the direction. That means now it changed its velocity with respect to time. Clear? So during a motion, what will change? The vehicle will change its speed along with the direction. That means velocity changes with respect to time. And this velocity change with respect to time is our new physical quantity called acceleration. And this is the definition of acceleration. You can define acceleration in two ways. Either you can use rate of change of velocity of the object. Here rate of change, it indicates that with respect to time, what is changing? Velocity is changing. So when you use this term rate of change of, no need to use extra term with respect to time. In this term itself it is there. Okay, so if we are using this definition, just write this only, that is rate of change of velocity of the object. Or you can define it like this: change in velocity with respect to time. Clear? So these are the two ways how you can define the new physical quantity called acceleration. That means whenever there is a sudden change in the speed, that means a gradual increase and decrease, that means it is not moving with a constant speed. Whenever it is changing its speed time to time, what term will come? Acceleration will come. And you know that in which case this change will come? It will be coming only in the case of non-uniform motion. Isn't it? That is what we studied. In the case of non-uniform motion, only what will be there? Acceleration will be there. Then why it is not there in uniform motion? What is the concept of uniform motion? Yes, motion is constant. That means speed is constant or velocity is constant. So in the case of uniform motion, there is no change in the velocity. That means if there is no change in the velocity, there is no acceleration. That is why in the case of uniform motion, there is no acceleration. That means acceleration is equal to 0. That we will discuss now. Okay. That means acceleration is there only in the case of which motion? Non-uniform motion. This is a very important point. Okay. So acceleration will have a value only if the object is in non-uniform motion. Okay. So acceleration can be defined as like this. These are the two ways how we can define, and the equation is acceleration equal to change in velocity. Change means final minus initial. Okay. So here the term is velocity. So final velocity minus initial velocity divided by time. And final velocity is represented by the term v, and initial velocity is represented by the term u. So acceleration is equal to v minus u by t. So this is the equation you have to remember, and SI unit is meter per second square. How this unit comes? From this equation itself you can find the unit. What is in the numerator? These are velocities. Final velocity minus initial velocity. So the term is what? Velocity itself, and the unit of velocity is meter per second divided by time is in seconds. So meter per second by second, that is meter per second square. Clear? And since acceleration is relating velocity, and you know that velocity is a vector quantity, so acceleration is also a vector quantity. Clear? So definition, equation, unit, which type of quantity it is. Clear? Now, there are two types of acceleration, that is positive acceleration and negative acceleration. This one already we discussed. Positive acceleration means we are speeding up. That means we are increasing the speed. Negative acceleration means we are slowing down the speed. That means we are decreasing the speed. That means deceleration, or it is also called as a retardation. That is when we apply brakes to a vehicle, what we are doing, the acceleration came, there is a negative acceleration, and it is also called as a deceleration or retardation. Positive acceleration is there in which situation? When we are increasing the speed of the motion. Clear? So in that way, there are two types of acceleration. One is positive acceleration, or we will simply call it as acceleration itself, and negative acceleration means it is also called as deceleration or retardation. As we discussed earlier, for a uniform motion, there is no change in the velocity, so acceleration will be equal to 0. And for a non-uniform motion, acceleration will not be equal to 0 because velocity changes with respect to time. So this point is what we discussed just now. Okay. Then, in the case of non-uniform motion, it can be splitted into two. That means in non-uniform motion, A is not equal to 0, isn't it? So if A is not equal to 0, there are two possibilities. What are the two possibilities? Either A can be a constant value. That means A can be same throughout the motion, or A can vary. A can vary time to time. Okay. So based on this, when A not equal to 0, there are two possibilities. One is A can be a constant value or A can be a variable. So based on this, there are two types of cases in non-uniform motion. Case 1 is uniformly accelerated motion. This is the first case in non-uniform motion, that is uniformly accelerated motion. That means uniformly, meaning is constant. What is constant? Accelerated. That means acceleration is constant. So in uniformly accelerated motion, acceleration will be a constant value. And here non-uniformly means not constant. Not constant means it varies. Clear? So A varies. So based on the value of acceleration in non-uniform motion, it has two cases. One is uniformly accelerated motion and the another one is non-uniformly accelerated motion.